All right, the STRIDE model. If you haven't heard of the STRIDE model, it's an acronym, and it's spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. We could do a whole another 1 to 2 hour webinar just on the STRIDE model. So if you're not familiar with it at all, then just do some internet research, and I'm sure you'll find plenty of information about it. But that is a way of thinking about the threats that you may need to design a security feature around. Ask yourself, in what ways could an attacker spoof an identity? In what ways could an attacker attempt to tamper with data? In what way could an attacker do something and then repudiate that it was done, or deny that they were the ones that did it, or make it look like somebody else did it? So it's a way of thinking so that you can design, you can identify threats for your particular software, and then help you to design software features. And when I say software features, I'm including code that runs in your cloud infrastructure, because it's all code, it's all automation, it's all something that you would put in your Git repository and ultimately get into production. Okay. So that's the STRIDE model. Just the last three, just for those who might not be familiar with it. Information disclosure is an information break or data leak, and because of it, public trust and thereby revenue can drop drastically when we see that happening. Denial of service is the system going offline by the actions of an attacker, and elevation of privilege is coming in, an attacker coming in with a lower level of access and then maneuvering in some way to get their account elevated so that they can do more things. Okay. When you're laying out a process, a product management process, which product management is kind of the beginning of DevOps, even though it doesn't have any DevOps automation. So a lot of times it's not talked about in the same paragraph, but everything that is deployed is envisioned in the product management process. So if somebody in product management says, well, we need the application to be secure, or you need to expand that conversation and talk about, well, what are we looking to avoid? Obviously, data breaches. What are we looking to accomplish? Well, we need to pass a particular audit. Like, we need to do a PCI audit. We need to do a SOC 2 process. We need to get some FERPA documentation because we're operating in the K through 12 education space. Whatever it happens to be, whatever the objectives are, state those objectives and then back it out to some product backlog items, some features that can then be designed with the hope of accomplishing those outcomes. And these are the main stages that any feature needs to go through for software. But let's talk about it through the lens of a security feature. And I'm going to show you a different view. From a process perspective, there's 4 different types of design activities. The conceptual definition is what a lot of people think of, requirements gathering. Just think of the requirements, the business requirements. User experience design is, how is a person going to interact with it? Technical design is architecture, design patterns, what libraries we're going to use. And then acceptance criteria or test design is asking the question, how do we know that we're done? And how do we know that it does everything that we needed to? And designing those scenarios to check in pre-production environments before we actually get into code. All right, so if we lay that process out on some swim lanes, out on a Kanban style board, then we have columns for each of these activities where we have conceptual definition, which is business level requirements, user experience design, technical design, test design, and then development. So if you're taking the security feature of making it possible to detect when an attacker is doing a brute force password attack trying to get into a user's online banking account, we would talk about the threat situation and conceptual definition, the fact that this does happen, maybe some data around how many times we found out that it happened last year. The user experience would we'd want to annotate the login screen and maybe the text that would pop up if it's happening. Maybe we want to warn the user that, if they have one more attempt that's wrong, it's going to lock their account and they have to do something. So legitimate users can kind of pause and try to maybe go back to their password manager and get their password or do the reset password loop. Technical design are things like, well, I'm going to have to remember when the last time they had a failed password attempt. So I'm probably going to have to add a piece of data to the current database schema. So you see those are the different types of, so it's just regular feature development. And then the test design is designing test scenarios of go through and log in fine, go through and have 5 bad password attempts within 1 minute, just all kinds of various scenarios. And so you design what you expect to happen. And the trick here is to translate from an objective, which is don't let bad things happen, and analyze what all your threats are and design features to do 2 things. One is make it less likely that the threat will come to fruition. And the second is, if the threat does actually occur, lessen the impact if it occurs. Design features around that, and now you have a security backlog. All right. Something else you need to know is the OWASP Top 10. And we always, at Clear Measure, we always try to simplify complex topics. And there's other people also that have simplified these security concepts. And OWASP is one of the organizations that have done a good job of it. And they've constantly published the top 10 most frequently successful attacks. And so in 2017, they had a survey, and in 2021, they had a survey. And not only did they publish the top 10 security vulnerabilities that are successfully exploited, but they also published the differences. And so we see that injection, not SQL injection is the most common type of injection, but injecting code was number 1 in 2017. It's still on the top 10 list, but it lost 2 spaces. Broken access control went from number 5 to number 1 from 2017 to 2021. And there are 3 new problems in 2021: insecure design, software and data integrity failures, and server-side request forgery. Those are the new ones. And the ones with the dotted lines were kind of eliminated and merged in with some others. But anyway, if you have not studied the OWASP Top 10, there's plenty of good material out there, and I encourage you to do that.